Okay, so let's continue working on what we talked about last lecture. We had just started creating a very simple Angular application that that we are enhancing an existing static HTML web application and converting it into a dynamic application using Angular MVC library. And we had just worked on two of those pages, the login page and the registration page. Notice that this is the beginning of a single page application where we are only ever loading this index page, right? And we're never leaving this page, the index page, right? Instead, we are navigating, like the hash sign suggests here, we're navigating to different portions of the index page, right? The hash navigation mechanism has been around for quite a while. It was usually meant to be able to have one large page, right, and perhaps different sections of the same page, and perhaps have either like a table of content at the top, right, that allow you to just click on that table of content and just go down and navigate on the same page, never actually leaving the page, right? And what Angular has done is hijack that feature, right, that mechanism, and wrap an entire framework around that idea. Okay, so that it registers with the browser saying, "Hey, browser, instead of what you normally do by default, right, what you normally do of trying to navigate to different sections of the page, instead, what I want you to do, browser, please notify me of any changes in the hash." Right? You can register with an event. You can register with a browser with events with JavaScript, and that's exactly what Angular does. Right? Angular listens for the changes in that hash, and then through configuration, through JavaScript configuration, through an API, you can configure to that event handler of listening for that hash, and determine that. And configure that if after the hash you see this URL pattern /login, this one right here, if after the hash you see that /login, then the following HTML should be loaded. Okay, we should go fetch that snippet of HTML and dynamically inject it into the index page at a specified location. Right, and that location is this one right here, ngView. Right, it's this empty div, right? That is where we're going to inject the content that we dynamically retrieve from the server. Now, if you'll notice, if you look at the source, the page source, this is what the browser is getting from the server. Right, this is the actual source code that gets downloaded of the HTML source that comes back from the server. If you'll notice, the content is empty. Right? It just has head and meta tags at the top, and the body is pretty empty. You don't have any of these fields and buttons and H1s. All that has been done after the initial download of the index page. You see that? If you look at the if you inspect and look at the network traffic, if you reload, you'll notice that first, the index page gets downloaded. Obviously, that's the very first thing that gets downloaded. And then the index page makes references back to the server asking, oh, I also need the bootstrap, so that downloads. The style sheet, that downloads. The Angular, the route, the app.js, and there's my config. Yes? And the config says, I'm going to configure and say, meaning, if you see the following URL, what should be loaded? Oh, okay, I need to go fetch from the server this snippet of code, this login. And indeed, that's what happens. There it is. The login.html is downloaded from the server and injected into the ngView. There's the ngView. See that? The ngView came from the server empty. There, see that? It came from the server empty. But the Angular library, following the configuration, yes, implementing the configuration, says, oh, I got to go fetch that, and there it is. What's that? this is the content of the login page right here, right? User login. There it is, my class container fluid. There it is, div container fluid. It fetches it and injects it into that div. Make sense? So that's what we mean by rendering on the client, right? The content obviously always exists on the server, right? All the HTML templates, all the CSS, all the JavaScript, that is still static content on the server. So from the server's point of view, this HTML is dead HTML. It's just static HTML. It never changes, right? But from the client's point of view, this is dynamic. Yes? This is all dynamic. It's going to go fetch snippets of HTML and it's going to paint the page following our configuration. Make sense? All right. All right. And if I change this to say instead register, if you look at the let's make this a little smaller. Maybe put this on the side like that. If I change this, oh, that's too small. If I change this to be register, and we look at the network, and change it to register, notice that there it is, right? That's the fetching of the register page. That makes sense, right? We're navigating to the register page, and according to the config, if you have a hash register, right, at the end after the hash, then we should go fetch the register. And indeed, that's what happens, right? There's a get HTTP request that goes out to the server, right? There's a get request, right, that goes and gets the register.html. Makes sense, right? It goes, fetches it, and replaces the content of the ng view, right? It removes the previous content of the login template, and it replaces it with the content of the register page, of the register view. You see that? All right? That's great. Now, notice, what if I want to go back? If I go back, right, typically in a classical implementation, if I navigate back, that would, the implementation would reload the page that I am now navigating to, right? I'm just going back to the previous page, right? If I navigate anywhere, notice that there hasn't been any HTTP requests back to the client, back to the server. See that? There was no HTTP traffic, right? These HTML snippets, these DOM, these HTML snippets are parsed by the Angular framework and cached, right, by the Angular framework on the client, so that it never has to go back to the server for this HTML ever again, right? Until you, obviously, if you refresh the page, this whole thing resets, right? If you refresh the page, right, we're not going to survive the session, right? We throw everything out. Any prior references are gone. But what I want to point out here is that Angular is maintaining all this cache, right, of all these DOM HTML that has been parsed already. There's no need to go fetch it from the server again. Make sense? All right. Okay, so let's keep going. Let's implement one more, the profile page. So let's go to the config and add just one more of these, right, and do the profile page. And this would be profile.html. If I refresh the page and instead here I type profile, again it's going to load the profile page, right? The color is a little different, I believe, because the profile is still, right, it's still behaving as a standalone HTML page, right, loading its own styles and whatnot. Instead, we need to configure it so that this behaves like a single page application, and this is now a snippet of code, not a full-blown HTML page. So let's reload that. There it is, right? This is the profile page with the style provided by the index page, right? The index page loads everything that is common, right? All the JavaScript and CSS that is common to all snippets of code, and provides the styling for all the other pages that are injected into the ng view. Everybody okay? All right. All right. But if you'll notice, these links, the login page, when if I click on register, that worked, right? What about if I click on login? Notice that it's loading the old profile page, right? The link is broken, but again, it's still implemented using the old-fashioned way of doing this, right? By literally referring to a document, right? So we need to update that. Let's go to the login page, and our hyperlinks, instead of referring to an actual document, right? Let's notify our central controller that we want to go to the profile, right? It is not the responsibility of a page or a view to know about the navigation, right? That should be the responsibility of a controller, right? Remember we talked about in the last lecture, we said that we're going to move away from having the logic of navigation spread over many artifacts, instead centralizing it into a single controller, into a single navigation controller, which is configured here by our config here, right? So now pages no longer will know explicitly where they're going. Instead, we're creating this little abstraction layer that they notify a central controller of the intent of the user. The intent of the user is that they would like to go to the profile, like an event, right? It is the responsibility of a controller to make that happen, right? It is not the responsibility of the view to make it happen. Make sense? Right? Same thing for the register. Let's see. Register also has a hard-coded link to the document login. Instead, we're going to change all these to hashes. Yes?
Is the hash
I'm sorry, say again?
using a hash in front of login?
Yeah.
Hash and a slash. Is that a convention that we are using, or is it a requirement?
No, well, it's required because we are changing the URL, right? We're changing the hash side of it, right? And this is a feature that has been around for quite a while, right? The way the browser interprets it is that the default interpretation is that presumably there is a section down somewhere in the page that has an anchor whose name is login or register or profile, right? And it will try to scroll, right, the page up and down looking for this anchor, but there is no anchor, right? Instead, Angular listens for these events and has all this single page application infrastructure to go fetch these snippets of code and replace the DOM. But yes, we need the hash there. Yes?
How is fetching these code snippets any better than just navigating through it?
We had talked about last lecture that when you have any number of pages, right, and each page physically refers to other pages, right, you have a dependency between the pages and other pages, right? And if you ever want to manipulate or maintain or change the navigation, maybe inserting a page in front of, say, when you're checking out before paying, I want to be able to verify something, right? And so I would need to change all the dependencies of navigating to that one page, right? Say there are 10 pages that are referring to this one page. I would need to modify those 10 pages and say, hey, now you don't go directly to this page. Instead, first go to this other page first, right? So maintaining it maintenance makes it much more harder, right? You have to there are many more artifacts to maintain. Because now your logic was spread across many artifacts, right? So the model view controller paradigm says that instead of having that spread over that many, instead centralize it. Put it in one single place so that you can maintain it in one single place, right? And that's indeed what we've done. We've put it in a single configuration file. It could be an XML file or a JSON file or something that perhaps you could attach a user interface where you can graphically drag and drop and manipulate the navigation, right? So it's a much better, easier way to maintain this using the model view controller design pattern. Yes?
So while working with Angular, sometimes I notice that if you use a higher version of Angular, you have to use hash as well as bang along with that.
Yes.
Is there why was that changed? Because I understand using hashes and go to a particular ID thing.
Yep. Yeah, that's for search engines, right? To be able to tag them, because search engines won't care about the hash, Afterwards, they'll only care about the document. But now using single page applications, we do care about the hash, right? And any parameters, because anything that follows the hash, we are using it to reconstruct the page, the state of the application, right? If we have a single page application, there's only one document that is ever loaded, the index page, right? Instead, we want to be able to remember or index, right? Pages, including the state information that was used to reconstruct the original page. Right. So those are things that are used for the search engines to be able to index not just the original document, but the entire state of the application. Yeah, more and more single page applications are becoming, if you use Facebook or any of the Google applications, Google Docs, Google Sheets, Twitter, they're all single page applications, right? Awesome. So this technique is we're following the philosophy of who's responsible for what, right? It is not the view's responsibility to control the navigation. Instead, in an MVC, the controller is the one responsible for controlling the navigation, right? Again, it's a design pattern. It's a best practice. So same thing here. This would be profile. Profile 2, do we have a couple here? Do we have a login? We have references to these, right? So there we go. This was hash login and hash profile. So if we go back and refresh, let's see if all the navigation works. Yes. Register, cancel still works, register works, register goes to profile, that's good. If we log in, we go to profile. If we log out, we go to login. So okay, so all our navigation works, yes? So say we do have to do some maintenance and somebody tells us, you know what, our application is getting out of hand, has way too many pages, we need to create a hierarchy of these things, right? Let's move a couple of these things. Also, you're not following correct naming conventions. You need to rename this according to the team. We've come up with a very good naming conventions on how to refer to these artifacts. And somebody says, okay, well, actually, a better name for this would be login, right? That's the name of the page. Its role, it's a view, meaning this is meant to be consumed by a human being, right? So this is presumably there's styling around this, right? It has nice white spaces. A human being is going to consume this, not some automated process. It's not data. It's meant for human consumption. Also, it's rendered on the client. It's dynamic content meant to be rendered on the client as opposed to rendered on the server, right? So this is a naming convention that our manager has come up with. And it's a convention that is used not exactly this, depending on different teams will come up with different naming conventions, but it's a very common thing to encode in the name of the file, right, the role of this artifact, right? It doesn't really matter if you only have just a couple, maybe a dozen of pages, but when you start having hundreds of pages and large applications, namings of these files are very important, right? It places the developer immediately. When they look at the file, immediately says, where does this, who's responsible for this, right? And also gives you a mental model of the organization of the application, which is very crucial on large, long-term applications for its maintenance. So anything you can do to make it easier for the developers to maintain this, the better. So you have view and client. So having changed this, you'll notice that all of this breaks, right? Obviously, the pages have been renamed, and none of our links works anymore. So the login page is being referenced by two pages, right? It's being referenced by the profile page and it's being referenced by the register page. Because normally, I would have to modify those two links, right? I would have to go and say, I need to maintain this. Anyone else who references the login page, I would need to go and maintain those pages. Instead, because I have a single maintenance a single place to maintain this, I don't have to update them, right? Because the links that they're using are high-level links, right? They're saying hash login. They're not referring specifically to this HTML. I can say here that this is actually going to be just .view.client, right? And just updating it here, I don't have to even touch those HTML documents. And now everything works again. So I can log in, and the profile, this link's logout still works, goes back. I didn't have to open up the profile page. I didn't have to open up the register page. Those still work. All right. So let's keep doing some more maintenance on this. Our manager says that this is getting out of hand. There's way too many features. There's a website feature. There's a widget feature. There's a user feature. Pages. We need to create a way to maintain to deal with the growing complexity of this, right? So they come up with another idea of creating a dedicated directory where we're going to put all the views, everything that has to do with rendering things on the page and dealing with user events. So we're going to move all our views, all our content into a views directory. So let's move that. Let's move websites. And let's move widgets. There we go. Again, all my links are broken, right? All my links are broken because I moved the HTML files. Typically, this would be something very, very cumbersome to maintain. But again, having a single point of maintenance makes it easy to just update in a single place. Even somebody could write even a GUI, a user interface that would allow me to just rearrange this, or a tool that would easily refix all of this. So if I go back, uh-oh, did I break something? Was it plural? Okay, thank you. There we go, and everything still works. Everybody okay? All right, awesome. Yes. 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 Right, so all of them would be using hash login, say, right?
So we have to go and change all the features.
No, because that hash login maps to this configuration, right? So if you have even 100 things that refer to the login page, there's only one place that you have to fix it, right? Only here. Okay. So let's keep going. Let's start working on the controllers that go along with this, right? So if I click on this button of logging in, if I click on the button, I don't want to blindly just go into the profile page. I need to look at the username and password that you entered, and look it up look up some user, whether that matches, right? One more thing here. Notice that my the attributes here in the input field are too wide. Well, obviously because I'm zoomed in, right? But something that would make this a little bit easier to read is that adding some white spaces, right, here in the attributes, just spacing the content, a little bit, so that I can easily read the various attributes for the content. So please add white spaces. Again, for whoever's reading your code, make it just a little bit easier to read and maintain, right? All right, so let's add a controller for this. So where do we add the controller? Where do we add the controller? One place that we can add it is right along where the HTML lives, right? Although you will find in a lot of documentation and a lot of design patterns, you will find that typically you have a dedicated controllers directory. Okay, and you would put all the controllers there. That's one way to organize your code. I prefer to put it next to, as close as possible to the HTML view or template, right? That is controlling controlling that template. All right. So for instance, we could do something like a controller here, something like login controller client. Again, the naming convention tries to place the developer, tries to give a clue on what's the role of this artifact, right? It's a controller, meaning presumably it has a template that is associated with this, right? It's receiving events from some human user, right? It's handing off those events to some backend, right? And then it's receiving data and then sending that data back for the client, right? That's its role as a controller, right? Again, Angular and many of these model view controller MVC frameworks, right? They force us to think in that design pattern, right? To split the application in those three buckets, right? So there's our controller. Also, this is a controller meant to execute on the browser, right? On the client, not on the server. We could certainly have controllers on the server too, right? And we'll see when we look at services that indeed you can have, sister JavaScripts, that talk to one another, one on the client on the browser and one on the server. We'll see that in a minute. So let's focus on controllers here, and in controllers, let's work on our very first controller here. Always any JavaScript running on the client, we're going to put it in an IFI statement. IFI statements allow us to create a self-contained namespace, right, that does not litter the global space of the JavaScript global space, right? The browser only has one single JavaScript namespace, the global space, right? And that space is being littered. Well, not littered. Is being shared amongst lots and lots of JavaScripts, right? Certainly Angular. Later on, we'll add jQuery, Bootstrap. We're going to put in here all those JavaScript libraries. We'll add many other different JavaScript libraries. Each one of those libraries might be declaring things on the namespace, right? On that one namespace. And so we don't want to inadvertently collide with functions and variables that those namespaces, those JavaScript libraries add to the namespace, right? So it's a good idea to declare everything within a self-contained namespace, right? That is inside of a function. A function, by definition, creates its own local namespace, right? That is not accessible from outside. So any variables that I declare in here are not visible from the outside world. Okay, but I still want the code that I put in here. I would want it to run and do something, right? And execute. And that's why you have the two parentheses here. It means that those two parentheses mean I'm an invoke. I want to execute something on the left, right? It's a parentheses. Presumably on the left-hand side there's a function that wants to be invoked, and indeed we invoke it, and that means run whatever we have in here. Okay, make sense? Pretty good. All right. So to declare controllers, we're going to grab the module, the same module that we've been working with. We're going to read it. We're going to grab it for read purposes. So we're going to retrieve it from the Angular framework, and we're going to add a couple things here. Right? We're going to declare a brand new controller that will have the name login controller, right? Implemented in a function of the same name. Okay, and we're going to say just to make sure that we're here, hello from controller. All right. So we declare this brand new JavaScript. What this JavaScript is going to do is that the framework, right, when it looks at controller, it's going to instantiate. It's going to use this function like a constructor, right? It'll create an instance of the controller, and it's going to bind the instance of that controller to a string, to this name, right? This name that can be referred to across the framework, across the web app maker module. It is known, this login controller is going to be known by its name within the web app maker namespace, right? We're going to be able to refer to this controller always within this web app maker namespace. Okay, and its controller, it means that it has certain, because we're declaring it as a controller, it has certain responsibilities, right? It has certain behaviors, right? For instance, one of its features is that it can be tied to a template. Okay, it can be tied to a template, and they can both now talk to one another, right? So to do that, we can configure and say that, hey, templates for login, your controller is that login controller that we just declared. Okay, that is your controller, right? So this HTML is now tied. This template HTML is tied to this JavaScript instance. Make sense? Right? And the yes. No, typically we're just going to have one template, one controller. Yeah. No, we're not going to have multi-controllers. You could have nested controllers where you could have a template that includes another template that includes several other templates, each template having their own controller. Okay, and that introduces a complexity that each controller has a scope, right? Variables and functions that are declared within the controller, and if you start nesting them, right? Like every scope, or the idea of a scope is that inner scopes inherit from higher level scopes, right? Which introduces a complexity of what if you have variables that have the same names in different scopes, right? You have variables in the inner scopes overriding variables or functions in a higher scopes, right? And you get this problem of asking yourself, if you see a variable, who's responsible for the value of this variable or this object? Which scope is responsible for giving you that value? And we'll talk about that in a minute. Right now, let's focus on this controller. So if we go to a login page and we reload it in the console, we're getting an error. Oh, I can't find the login controller. Oh, okay, somebody's referring to it. Right. We never loaded it. Let's go to the index page and load that JavaScript which we just created. Oh, we did. Did we? Oh, this is for the other class. Sorry, this is the Wednesday night. Let me close this. This is here. This is here. Yep. Okay. Yeah, this is all the right files. Okay, very good. So if we reload, let's load it from our index page. Where's our index page? It's right here. We never loaded that controller we just declared. So let's load that right here after the config. Let's load src under views and under user and under login control. There it is, right? There's our controller. So if we reload that, notice that indeed that controller was instantiated because we're looking at that template, right? We are at the hash login. The correct template gets loaded. The correct controller gets instantiated. Okay, and now they're bound to each other, and they can start talking to one another, right? So the controller might, for instance, send data to its template using the scope variable that we talked about before, right? We can say scope hello, right? And any data that gets associated to the scope, right, is readily available in the template associated with it, right? So for instance, in the login template, we can now catch that hello, right? The hello. We can now, for instance, do the following, right? We can say hello, right? So this variable was declared where? In the scope of the controller responsible for that template, right? So these guys have now two-way communication between the two. If I refresh, Indeed, we see that says hello from controller, right? These two, the controller and the view, are now talking to one another. Make sense? Okay? All right. All right, so let's keep going. But we're not going to use the scope. We're not going to use the scope. Because of what you pointed out earlier, right? If you have nested controllers or nested views that embed other views, right? And each view having their own controller, you might get into this problem of that hello variable here, this hello variable, who's responsible for giving me the value of that variable? Is it my controller, or is there maybe a controller above me, right? So we in programming, typically we don't like to have variables that are just tied to no context. We want to know exactly who's the context in which this variable has any meaning, right? That's why functions have their own curly brackets, right? That's why we do modular programming. That's why we do reusable code. We want to make sure we control at all times the scope, right? And understand what is this tied to. We would like to know, for instance, that it's my controller, right? It's my login controller somehow, right? That's giving me that hello, not a parent controller or some higher a level up, right? That's why we don't use gotos. That's why we don't use global variables, right? We don't like to deal with side effects, right? And we don't want that somebody's changing the value of a variable and somehow that's affecting some other part of my application, right? We want to make sure that we always have a very narrow scope, that we know who is responsible for the data, right? So to do that, instead of using scope, we're gonna tie the values, the data. We're gonna tie it to the instance of the controller itself, right? So that whenever we try to access it from the view, we know exactly where it's coming from. Indeed, we're gonna tie it to the instance of the controller. So we're gonna create a little variable. And we're going to tie the instance of the controller. We're going to tie it to that local variable. VM, meaning view model. View model. Model as in a bucket where we are storing data, right? Perhaps it has a schema, right? It has a particular structure, right, to it. And view, meaning it's meant for the view. It's meant for the templates. This data that I have, right, has a particular structure, and it's a convenient structure for the view. It's not model, the big model, as in the back-end database model, right? That you might have, many-to-manys and one-to-manys and foreign keys and all, what would entail a real model, right? Which we haven't talked about yet, right? It's not that model, right? It's a subset of that model that has a particular structure that is convenient for consumption by the view, for rendering purposes. Yes, the model, the real model, might be very normalized, right? It might be very hierarchical, right? It might have lots of references between various instances, rows and columns, referring to each other, right? And it has gone. Who's done 5200 here or 3200? Anybody? No 5200? Or a few? 3200? Anybody? No? Okay, then I'm not going to talk about data modeling. Typically, when you're coming up with these applications, you try to find all the entities, right? All the pieces of data and how the data is related to one another, right? If you have one developer and you have many websites, how many do you have of each other, right? Is there one-to-many relationship? Is there many-to-many relationship? Is it just one developer creating many websites, or are there many developers creating many websites, right? And those kinds of the collection of all this data and how it's related to one another is what we refer to as the model, right? And we'll talk a little bit about it when we get to MongoDB. And So typically the view, and for the purpose of the view, whatever the user is looking at a page, it's always going to be a small little snippet, right? A small sliver of the real data, right? And it should be structured in a way that is easy to consume for the human being, right? In particular, what's useful to render a particular page. Yes. For instance, if you're checking out, right, the checkout process might involve 3 or 4 pages, right? There might be looking at your shopping cart, providing the billing information, providing the payment information, right, and then verifying the payment. And you spread it out over 3 or 4 pages, only for the convenience of the user, right? We present it as if it were like a wizard, right? We present it. It's only for the convenience of the user, but indeed in the database, in the back end, not necessarily the data is going to be structured that way, right? It's going to be structured just as a single order line item, right? And then the products associated to that line item would be listed in a different collection, right, or a different table, right? So the way it's represented in the back end, it's not necessarily the way it's displayed in the content. Make sense? For the same piece of data, there might be different ways of representing it in the front end, right? If you have three data points, X, Y, Z, or X, Y, say, right? You could represent it in the front end as a graph, right? Maybe lines, or you might represent it maybe in bar charts, right? Or maybe you represent it as a pie chart, yes? So the way it's represented in the view not necessarily has to be the way it's represented in the back end. That makes sense? Right? For the same piece of data that you might have in the back end, right, you might have different views onto the same data, right? So this is what this VM over here means. This is data that is meant for consumption for presentation purposes, right? Not necessarily the model in the back end. Anyway, we're going to tie data to the VM. So we're going to say VM hello from the login page, login controller. All right. And if we go back to the login page, our hello no longer would work, right? If I re-render, notice that hello doesn't render anymore, right? Hello doesn't render anymore. It makes sense, right? Because the string is no longer bound to the scope, right? So the view, when it sees this hello variable, it says there is no hello in the scope, so there's nothing for me to render, right? So where's the string now bound to? Not to the scope. Instead, it's bound to the instance of the controller. So we need a mechanism for the view to be able to fetch the instance of the controller, and Angular allows that, right? Angular allows that. It allows us to tell the template that you can refer to the controller. You can refer to the controller as, and then whatever you want, right? The name that you want to refer to it in the view. So say XYZ. I want to be able to refer to the instance of this controller using this variable XYZ. So now in the view, I can refer to that controller by the name I just chose, XYZ. All right. So I go back, and we're back where we were just a minute ago, right? We can refer to data that is declared on the controller, right? And the controller can send data to the view, and the view can send data back to the controller, and they can talk to each other through this instance variable. Make sense? Ever still with me? All right. The only thing that this buys us, notice that it's not very different from using $scope. But the reason we're not using $scope is because of if you have many controllers, you want to make sure that they're not littering each other's scope. Yes?
So is it different from doing login controller?
So login controller is this name login controller is not visible to the view. The view doesn't know about this variable login controller. Okay, right? Because earlier you saw me do this. right? Okay, sorry, I didn't mean to. This name is not known to the view, right? It's known to the config. The config knows about it. There it is, right? I could do this, for instance, bind it to the same variable, a variable that has the same name of the controller, right? And that would work. There it is. It does work. We could do that. Come up with a convention, right? That our variables are going to have the same name as the names that were declared in the controller. Yeah, we could do that, but it would be by convention. It would be a convention. A more common convention that you see in the industry is to use model, right, as a very common name to refer to your controller, right? So you'll see a lot of this where this is model.hello. I don't necessarily agree with it, but this is a very, very common thing that it's done in industry. Okay, and again, this is not to mention it again, but this is referring to the lowercase model, right, of the view, not the model in the backend database server side, right? It's the client side view model. Okay. Also, this is also very common to use the variable VM. The variable VM, again, convention. It's only a convention, right? Very common in the industry to use VM as the name of the variable to hold the data between the controller and the view. All right, let's keep going. Yes?
The dollar scope, does it enclose the model, or is there something? Is it like dollar scope dot model dot hello?
No. This VM is nowhere inside of the scope, right? Unless you would do something like this, right? If you would do explicitly, you would say, $scope dot model is equal to VM. Then yes, then you would be able to access it from there, right? But no, we're not doing that. We're not using the scope at all. Okay. All right. So not only can we tie data to between the controller and the template, we can also tie functions. We could say vm.login, right? Tie it to a function, right? So that from the templates, let's remove this. From the templates, we could tie this login button instead of blindly navigating to the profile page. We can notify the controller model.login, right? Invoke a function declared on the controller, right? And this would say console log login button clicked, right? So that if you refresh and you click on the login, we see that the controller is receiving this event, right? We are interacting with the UI, and we're notifying the controller of our event. So since this is receiving events from the user, we typically refer to this. We refer to this as an event handler, right? We refer to these as event handlers. It's a function that is receiving an event from the user interface. Okay. I don't like this syntax. Instead, what I'm going to ask you to do, instead of using this, declaring this as an anonymous function, notice that the function has no name, right? So it's anonymous. I'm going to ask you to instead declare this function to be an actual function that has a name, and then binding it to the VM like this, right? And this does exactly the same thing. If you refresh, it works exactly the same way. But I think this is a little easier to read, just a little bit easier to read. Very much like typically when you're writing a function, typically what you do is that you declare all your variables at the top, right? That's very common. So same thing here, we're declaring login as a variable, right? That references a function that is declared down below, that's implemented down below, right? Also, the benefit of doing it this way is that if you have many events handlers, say you have tons of buttons, right, and a lot of events that you can generate, from the client side, right? If you want to create functions here for each one of those events, you would have lots of functions at the very top. Functions, 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 functions. And for me to read your code and try to understand all your event handlers, you're forcing me to read your event handler, the function, then some event handler, and then the function, then the event handler. It's very hard to read. Instead, if you declare all the event handlers at the top, like this, and then you implement it down below, right, it's so much easier for everybody else to read it, right? I could open up your code and immediately see in the first 10 lines of code, right, it says, oh, you have all these events handlers, right? There are, so this controller is responsible for these 10 or 20 events, right? If I want to read the implementation, I can scroll down and read the implementation, right? But you're not forcing me. You're not forcing me to scroll, right, just to look at all your events. Yes? So please follow this structure, right? Declare the event handlers at the top and implement it at the bottom. Everybody okay? All right, let's keep going. So this login page, what we want to be able to do is pass or receive here a user object from the template, and pass here a user object to the controller that has all the data that we need. Right? We want to be as object oriented as possible. We want to make sure that the communication between the controller and the template is as object oriented as possible. So yeah, there should be some object that captures all the information about the user. And right now, the only real information that we want is username and password. So let's bind this input field using ngModel. We can bind this input field, the value of that input field, to an object user that has an attribute username. Okay, and same thing with the password. ngModel user.password, right, and pass that user object. This user object, which is a local variable, and pass it to the login function over here. So we can now display the user right here. Okay, if we refresh and we type something, we click on login. Notice that indeed we get that object instance on the controller, the password and the username, right, are being passed on to the user. Everybody okay? Yep. Notice what I did not do. Where would this also be available, this object? This would be available in the scope, right? If I do scope, $scope.user, I would see that object. You see that? Right? If I say, right, in the scope, if you say $scope, and you print $scope.user, you'll get something similar, right? Both objects, right? This is through the scope, right? And this is through the function invocation, right? But we said we would not use the scope, also because notice that this is not an object-oriented way of programming, right? I'm not passing data explicitly through an API, through a function call, right? This is a very well-defined API between the templates and the controller, right? I'm explicitly passing you this data. Instead, this is a side effect, right? There is this magical scope variable that ties us together, right? And I can access the data through a side effect. And again, we want to avoid side effects. No side effects. We want to be very, very specific when we pass data between different layers, right? Make sense? Right. All right, so we have a login. So what do we do here? So we need to be able to search whether this user exists, this username and password, they exist. So how do we do that? We need somewhere that is hosting all our data. In our case, is hosting the list of users, right? Alice and Bob and Charlie and Janunzi, right? We want to host them somewhere. We certainly don't want to host it here in the controller, right? That is not the role of the controller. The controller should not host data. That is the responsibility of a model, right? Which we don't have a model just yet. But between a model and a controller, typically there's another layer in between, right? which is usually referred to as a service layer. Service layers allow you to encapsulate the access of data, right? They're not responsible of knowing how the data is structured or any relationship between the data points or anything like that. They only serve the purpose of providing data, right? And providing maybe the life cycle of that data. Now, being able to create instances, remove instances, update existing instances, right? Finding existing instances, right? That's the role of a service. They don't care whether there's certain relationships between the data points. That's the role of the model. All right, but we don't have a model right now, so we'll create a service that will for now play both roles, right, of the model and of the service. Okay, so let's do that. Let's what we'd like to be able to do is some bucket, right, that can give me access to the data, and typically these services are going to provide all the lifecycle methods, being able to create, remove, delete, update, and read these entities, right? So in our case, I like to do some user service that would allow me to do something such as, hey, find me a user that using the find user by credentials, right? And I will pass you the username. I will pass you the password, right? And if you find it, give it back to me. Right? Give it back to me. Login user. Give it back to me, and I'll check to see if the login user is not null. I'll do something. Otherwise, I'll do something else. Right? If it's not null, then I will log you in and allow you to go to the profile page. Otherwise, I will show some error message saying no such user found. Right? So we need this bucket, this user service bucket. If we load this, you'll notice that it's complaining, saying that I can't find this user service that you're asking for. Right? I can't find it. So let's create our user server, our very first service, and we'll create it in a directory called services, and we'll create a JavaScript under there called user.service.client.js. Right? Notice the name that I chose. Service, the role that it plays, right? Meaning this will give us the responsibility of services is to provide some very well-defined API that allows us to access data, remove data, update data, find data by various criteria. Okay, so let's implement that. And notice it says .client. That means that this is meant to execute on the client, meant to execute on the browser. Typically, all these client-side services will have a sister server-side version of this, right? That will be responsible for actually fetching the data from the database, right? Which we don't have just yet, right? Since we don't have that yet, we're going to mock the data. We're going to dummy the data inside of the client-side service for now. Okay, we'll change this in our fourth assignment. Wait. Fourth assignment. No, third assignment. Okay, so let's implement our service. Right, by implementing this using same thing, Angular. We're gonna fetch the that module that we're implementing, Web App Maker. Okay, and we're gonna create our very first service right here. Right. So we're going to create the service by using the factory method. What the factory method does is that it uses a design pattern called the singleton pattern, right? That creates an instance, right, and a single instance, and it binds it to a very well-known name. Then you can then use that name to to request the instance by name, right? So let's do that. Let's create here and declare a user service and implement the user service in a function of a similar name. A function service. Okay, and this is going to host all our data. Right, for now, we're going to change this a little bit when we go to the third assignment. Fourth assignment, sorry, when we get to server. Let's see, we gave you some data to play with in the third assignment. We gave you a list of users. I'm going to copy that. Where is it? There we go. We have this list of users. I'm going to copy that. And we're going to create users. It's going to have, for now, this is going to be our data model. Right? All our data is here. All the collections of all the users are here. And now we're going to create an API that will allow us to access this data, right? Or update or create or delete or manipulate this data. And we're going to create an API that will include functions such as find user by credentials, implemented in a function of the same name. And we're going to return the API right away, right? So services can be implemented in two different ways, right? There are two functions that basically do almost the same thing. One is the dot factory function, right? The other one is the dot service function, right? And the dot factory, what it does is that it calls your function, user service, in this case. And there it is, our function, user service. It calls it. It declares everything that is in there. And whatever you return, right, whatever the function returns, it binds it to this name, right? And now that name is registered with the rest of the framework, right? So that anywhere from the rest of the framework, you can ask for this service using a technique called injection, right? Angular also sometimes refers to this as inversion of control. Inversion of control is an idea that has been around on the server-side technology for quite a while, for a couple decades. Java uses it extensively in the J2EE framework. .NET uses it extensively. Yes?
So where is the file structure of this user service?
We put it under the directory services, under here.
And then do the other files that
There they are, under services. I'm sorry?
if I'm a file and I want to inject this into my file, do I have to be anywhere specific in the directory?
No. Yeah, just by declaring the name, right? I am registering this object, right? I am registering with the user service, right? And anywhere in the for instance here in the controller, just by asking it by name, right? It will be injected in here. Okay. This idea has been around for a while in Java and .NET. After we invented object orientation, we were saying, well, what's the next thing, right? That was an awesome idea when we came up with object orientation, classes and instances and whatnot, and inheritance and all those great things, right? So what's next? So the next big idea was component technology, right? As software became more and more complex, we were looking at other abstractions that we would come up with that would make our software development efforts easier, right? And we looked at other industries for inspiration. One of them is the way electrical engineering and electronics in particular, they have what is called an electronic bus, right? A data bus. That if everybody follows the same idea, follows the same design for that bus, if you build a component that has the interface that can connect to that bus, you can then have many components talking to one another and sharing data amongst themselves, right? That's a great idea, right? If we can all agree on the bus, you can put lots and lots of things together, right? And you see that a lot in hardware, right? You have USB, and you have now USB-C is becoming kind of like a standard that allows you to connect all sorts of things, right? And daisy chain video monitors and hard drives, and you can daisy chain tons of these things, right? If we can all agree on the standard, correct? So software engineering says, oh, can't we have something similar in our world? Something equivalent to that, maybe call it a software bus instead of a hardware bus, where we can just plug in components and somehow they magically talk to one another, right? But that means that we all have to agree what that bus does, right? And certainly within the Java world, within the J2EE world, they came up with their own component technology. .NET came up with a competing component technology. And if you follow the standard, if you write a Java class following the standard, following the Java Bean standard, right? You have setters and getters and all those attributes. You all of a sudden inherit tons of really cool powers, right? You can be easily stored in a database. You can easily be reinstantiated from a database into RAM. All these really cool things. All of a sudden, you can participate in lots of standard services like security services, multi-threading, memory cleanup, all this garbage collection, all these great services that now as a software engineer I don't have to write those things, right? Just like when I move into a building, I'm assuming that certain services are there, right? I assume they're going to have lighting, I'm going to have plumbing, I'm going to have lighting, I'm going to have air conditioning, hot water. Those are services that I don't have to build, yes? I assume that the infrastructure gives me those services. I just have to move in. I assume that those services are there. Same idea here with component technology, right? You write a piece of code, a piece of Java class or .NET class, right? And you just drop it in one of these containers, one of these software buses, and you're already secure, right? You don't have to deal with security. You don't have to deal with multi-threading, right? The software bus does that for you. So one of the big ideas now that component technology was the rage, we started building on this idea, and it says, you know what? Instead of me having to deal with security, right, and having to deal with whoever, I want to know who's logged in, who's currently logged in. Oh, the security service could tell me that, right? Because I don't want to have to write code to do that. I could ask the security service. The security service should be available to keep some session of the currently logged in user. They have already logged in. They already know the username and the password. There's some identity associated with that user, right? I should be able to just, hey, user service, come here. I'd like to ask you who the currently logged in user is, right? So how do I get hold of this user service? Right? So they came up with an idea of inversion of control, right? Injection. Right? I like to be able to say magically hash or at, right? Security service, and declare a variable, and all of a sudden, magically, my variable had an instance referencing the user service or the security service, right? With its own API, with its own interface, and I could ask it current user, right? And it would return to me an object representing that current user, right? Like magic. And this idea has been around for quite a while. It's very, very mature on server-side technology, right? J2EE, if you use beans.xml or these types of inversion of control in Java or .NET, and it works very well. And today's software is heavily based on that. So Angular and many other model view controller libraries says, ooh, we want something similar on the client side, right? That's a great idea, right? Instead of me having to encode all these things, I want to be able to create a single place that I can then reuse all over the place just by naming them, just user service. Anybody who wants to talk to the data about users, finding users or creating users or deleting users, they just have to mention user service, right? A single point of maintenance, and anybody can use it. So there it is. User service is injected in here, and we can start using its API. In this case, user service find user by credentials. Everybody still with me? Right? We'll be using this quite a lot, so I hope the more we use it, the more natural it will become. Right? We'll use it. We'll do it quite a few times, and then hopefully it will become natural to you. Yes.
Shouldn't it be user service, not API, not
So what happens here is that whatever I return, I'm returning this object, this map here. Okay. Whatever I return is what this gets bound to. So this gets bound to this object. Right? Not API. API is a local variable that references that object. Okay. So
user service is just a variable that this function returns.
yes, exactly. It returns, what does it return? It returns this object right here. Okay? And what is that object? It's a JSON object that has an attribute and this function that we never wrote, right? And that function references this function over here. So that if I do user service, what's this? It's what? It's this, right? It's this object right here. And when I say dot find user by credential, it's what? It's this attribute right here. Right? That is whose value, the value of that attribute is this function which is declared down here. Right? So that's how the mapping of this maps to this function. This function really doesn't matter what the name is as long as it maps to this. Okay? But outside is known by find user by credential. Right? The value of this is this value, which happens to be this function. But to keep it straight in my head, so that I know what is what, I tend to use the same names here. Okay, so these names are the same names as this. By convention, only by convention, right? All right, so let's play around with this. So login controller, user service. For now, let's return something. Find user by credential. Let's return the first users 0. Okay, user sub 0 is who? It's Alice. Yes, it's Alice. So here, let's print out. Let's do console. Let's do if it's not null, I'm going to print out the login user. Otherwise, I'm going to print out user not found. So if I refresh this, still doesn't know user. Oh, we never loaded the JavaScript. Don't forget to load the JavaScript. We just declared user service, so let's load it into our index page. So let's load that service. So services user service. So if we reload and we type something bogus and we try to log in, it returns Alice. Huh? Oh, right. We are hard-coded returning Alice. Yes? Yes.
So, since our index page is like a container and it will load every other page within ngView.
Yes.
So if you have like 10 different modules and those 10
Yep.
different modules have like 10 different JS, and
Excellent. Yes, excellent question.
should everything be loaded inside the index or inside those particular?
So we only ever have one single page in the HTML that loads everything, right? And because we're using config, it loads only the templates that it needs as you navigate, right? And when you get to a template, it navigates, it loads only that snippet of code. It doesn't load all the HTML, only the ones you navigate. But because the way we're using the scripts here, they're declared all on the index page, these JavaScripts are all loaded, even if you don't need them, unfortunately. Okay? If you have hundreds of JavaScript, they would be all loaded. That's a big problem, right? If I'm following a particular path and I never need some of these JavaScript, they would have been loaded anyway, right? So typically, what you want to do in a production environment, you would use. So this is the default behavior, right? You can't do anything about it. ideally you would want to have the script loaded on demand, right? Only the ones you need. Meaning that if you go to a login page, I would like the login controller and the user service. Only those two. I don't need the registration controller. I don't need the any of the other JavaScript, right? But they're loaded anyway. To deal with this issue, there are libraries that deal with this problem. One of them is require.js, is one of the more common and more popular libraries that allow you to declare dependencies, right? That says that if I am here, I need these other JavaScript files, right? And if I'm over there, I'll need those other two JavaScript files, right? And they're dynamically loaded only on demand, okay? To deal with exactly that problem, right? And I'll cover require.js a little later, to deal exactly with what you just mentioned. Okay. Yeah. So where are we? Okay. So this is always returning Alice because that's exactly what our service is doing. Instead, the service should do something such as accept the username and the password that is being passed here, iterate. For var u and users, and if user sub u, or find, let's see, var user equal user sub u, if user dot username is equal to username, and user dot password is equal to the password that you're passing, right? If that's true, then I'm going to return user. Otherwise, outside of the loop, I'm going to return null. I did not find it. Something like that, right? Something like that. So, for instance, if I log in, if I reload this and I type something bogus, I click on login, it says user not found, right? But if I type Bob and Bob, right, it returns the object of Bob, right? Make sense? Everybody good? Right. Notice here, those that are familiar with Java or .NET, this U here behaves a little bit different from what you would expect, right? In those languages, U would be bound to the various instances of these objects, right? Not in JavaScript. In JavaScript, unfortunately, U is just an index. Right, it's just 0, 1, 2, 3, 4, right? The index of wherever instance you're looking at, right? That's why I'm using it here as an index, right? Also notice my triple equal, right? It doesn't, in this particular case, we don't have to be a triple equal. A double equal would work just the same, but it's a good practice to use triple equal instead. Because triple equal not only compares that the data are the same, but they're the same data type. Okay, that you're not using casting, right? For instance, with double equals, the number 1 and the character 1 would be equal, right? Which says yes, they're both the same, and they're not, right? With triple equal, it compares first that they're the type are the same. You're comparing a character with a character, a number with a number, and then checks the value whether they're the same, right? So if the types don't match, it's false. Make sense? So it's a good practice to use triple equal instead of double equal. Yes? Yeah, and you want to catch those errors. You want to make sure that you're doing strong typing, right? As much as JavaScript will allow you to do strong typing. Right, but as much as the language allows you to do strong typing, that strong typing is a good thing, right? You want to make sure that all the data types are always what you expect them to be, right? And not some interpretation of the language that they're the same, all right? All right. Very good. So now that we're in the login page and we indeed have been able to log in, or if it's error, how would we notify the user if there was an error? Well, what we could do is provide here a vm.error, right, and provide some feedback to the user. Yes, a binding an error message to the VM, and then on the client side, right, on the login side, we could do some error here. We could say, vm.error. That would display only if there was an error. So that we could, so if we do some bogus login, we can say login and it doesn't work. What? There, refresh. Model.error. Oh, thank you. I hate computers. Refresh. So if I do this, notice it says user not found, right? Or we could go a little further and style this from Bootstrap. We can go fetch one of our components, an alert component. The alert components, we could use like this red one over here. Copy that and put this inside of a red box, right? And if we refresh the login page, and if we do something weird, we'd say login, it would display user not found, right? The problem is that this red thing is always showing, right? Instead, we would only want to show it when there is an error. So what we could do is use an ng show. Ng show is a Angular directive that checks to see if whatever expression you have in here is truthy, something that is not falsy. Okay. So for instance, you might say model error. Show if model error is truthy. Truthy means not empty, not undefined, not null, not zero, right? All those things are considered falsy. Again, oops. Here we go. Here we go. So there we go. So if a login does not show unless there's an error message. Okay, everybody good? All right. What about the success? Whether we successfully navigate, we found the user. If we found the user, we would like to navigate to the profile page. Yes, and to navigate, we want to dynamically or programmatically navigate to that page. We want to use the normal mechanisms that we're using, right? Using profile or register these hashes. We want to navigate using the hashtag, right? That's how we want to navigate. So what we're going to do is that we want to modify that URL over here. We want to change this from login. We want to change it to a profile, right? And navigate to the profile page. Yes? So to do that programmatically, we're going to use a location service. The location service allows us to modify that URL programmatically. All right. What we're going to do is we're going to say location dot. I want to modify the URL. Now, not the whole URL, mind you, right? We don't want to leave the index page. We want to stay in the index page, right? But modify the URL. And the URL, the only meaningful thing that we can change is everything after the hash sign, right? We should never modify anything before the hash sign because we never want to leave index page. We are a single page application. We never leave index page. So what I want to do here is modify the hash sign so that now it reads profile, hash profile. Okay? So if we refresh and go back and refresh this and if we type something bogus and we click login, we don't have that. But if we click Bob, we do programmatically navigate to the profile. But whose profile is this? It should be Bob's profile, right? Not just any profile. So this page should be dynamic page. It should not be always statically just an empty profile. It should be Bob's profile, right? So how do we do that? How do we distinguish whether this is Bob's profile or Alice's or Charlie's? Right? Somehow we need to codify in the URL the state, right, of the application. We want Bob's profile or Alice's profile, and we're going to use an identifier, right, a unique identifier. And if you'll notice in the service, we indeed have a unique identifier for each one of these. Yes, right. So what we could do is pass that as a parameter, right? We could say that it's not just going to be the profile, it's going to be a profile followed by some identifying information, right? Some user ID, okay, that I'm going to pass you. Notice that it says :UID, right? Meaning this is not hard-coded, it's whatever follows the slash something. Make sense? So this would so profile is no longer mapped to anything, right? Slash profile is not mapped to anything, but slash profile whatever is mapped to profile template. Yes, right? But presumably this will be some ID that matches Bob or Alice, right, or Charlie, and that would render those there. Make sense? Right. So let's do that. Let's have a controller for the profile. Let's have a controller for the profile that is able to fetch that user ID. So we'll have here profile controller. Okay, and it's going to be referenced by the view also as a model. Okay, so let's write that controller for the profile controller. Oops, do I have an error message? Oh, thank you. Yep. All right, so so in the views, in the user, I'm going to create a profile controller. Notice that this is already getting a little bit out of hand, right? There's 3 templates in there. There's going to be three controllers in here. It's growing, right? It's becoming complex, and I might have error pages. I might have all sorts of things, right? So I'm going to deal with this growing complexity by, again, going hierarchical, right? Breaking up things. So one common way to break up things is to have a directory for controllers and a separate directory for templates. Okay, so for instance, we would move all our templates under templates, and we would move all our controllers into our controllers, right? Controllers. We need to change a couple of things, right? The config file, for instance, we need to tell that these now live under templates, right? And the controllers in the index page, these now live under controllers, right? Again, whenever things start to get out of hand, right, we go hierarchical, right? Because we are human beings, and we like hierarchies, right? It's one of the ways that we deal with complexity, right? Where we have higher level cognition, and then we have all sorts of abstraction layers. Yes.
Right now we are just dealing with 3 pages. So if the pages grow, won't the SIC script be able to also do it, right? So on the next page will have only a long list of scripts and
Yes.
then so it's going to go to do we need to handle that?
Yes, we mentioned that. Someone asked that already. That we would deal that with require.js. That we would only load the JavaScript on demand. Right now, all the JavaScript is being loaded. Right. When the index page first loads, it loads all the JavaScript, even the ones you don't need yet. Right. And so to deal with this, we're going to use require.js as another library that allows you to create dependencies. Right, and say that, when I'm at this position in the application, only load the things that I depend on for that particular location. If I'm somewhere else, I'll load these other libraries that I need, right? And we'll deal that with require.js a little later. Yes? But yeah, excellent question. Thank you.
And like we did right now, we need to directories like templates and controllers.
Yes.
Whenever we do that, we will have to change the path.
Right, exactly. So right now, exactly, the way require.js works is that just like in config, there's a single place. There's a single place where you declare all your templates, right? Require.js is similar, right? You define all the dependencies, right? So all the JavaScripts, all the modules, all the services would be registered with require.js, and you give it an abstract name. You give it just like we're given these templates abstract names, register, login. These are all abstract names, right? That hide where they actually physically live. And then once you give these names, you can then you can create dependencies and saying, if I'm here, load these things that I named something, 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 X, Y, Z. Right? Require.js is going to solve all those things. Excellent, excellent. All right, so the profile controller. So let's build a profile controller. Let's declare it. I always forget to declare it in the index page. Let me do that right away. I'm going to declare the profile controller, right, and implement it right here. So this is profile.controller.client.js, and in here I'll build a very quick controller inside an iffy expression. Right, so this would be Angular module web app maker, and we're going to define a new controller called profile controller. Oh, I can't type today. Implemented in a function of the same name, right? Same thing, var vm equal this, right? And what we want to do here is that this controller is going to be loaded when the profile view is going to be loaded, yes? And what we want to be able to do is capture that parameter right there. It's 123 or 234, right? So that we know who just logged in, right? Because it's being passed on to us. Actually, are we passing it? I don't think we are, right? Let's do that first, right? Let's do the login. In the login controller, right? We're just going to profile act, really? We really want to do slash and then the ID, right? Where's that? It's in login user dot underscore ID, right? Right. That's how we stored it in the service, right? These are all the users that we're passing around, that we're returning, and that user object has an ID there, right? An underscore ID. So let's try that. Let's go back to the login page, and if we go Bob and Bob, we go to login page. Notice that it's 234. See that? If instead I log in as Alice, and Alice, notice that it's 123. See that? So it's changing depending on who I log in. So we need to fetch that ID. So how do we do that? So from the login controller, from the profile controller, right? We want to parse that URL parameter, and according to the configuration, the name of that parameter is UID, right? What the route mechanism is going to do is going to already parse the URL for us, is going to bind that value, whatever that is, 123, 234, is going to bind it to a map, a little map, right? It's going to make, if there are many parameters, lots of parameters, right? All the parameters are going to be nicely parsed, right, into this map, and they're all going to be named, right? And the names are whatever we named them in the configuration, right? So from the controller, we can fetch that using route params. So route params allows us to retrieve that map of parse attributes, and we can receive the user UID, the user ID. We can retrieve from user params, and then from the map call UID, right? And this name is the same name as here, this UID, right? And so here we can then do a console log user ID, just print it out. So let's try it again. Let's go to a login page and look at the oh, why is it so small? Login, if we go Bob and Bob and we log in, oops, no, sorry, Bob and Bob, and we say login, we went to the profile. Did I load? There it is, the 234. See that? 234. Or if I log in Alice, and log in, notice this is 123. See that? All right. So we have that ID at the controller. We only just need to go fetch that user for that ID, right? For that, we're going to be using user service again. User service, right, is going to provide that API for fetching that ID. So for instance, something like, instead of find user by ID, we're going to have a find user by, instead of having user by credential, we'll have user by ID, right? Which will be very, very similar to this function, right? Almost the same, but it'll be find user by ID. And it's going to take as argument the user ID, right? And we're going to compare if the user underscore ID matches the UID as an argument, then we're going to return the user that we found. Otherwise, we're going to return null, right? So from the controller, right, we can retrieve var a user using the user service, find user by ID, and pass user ID, right, and display the user, right? So if we there it is, this Alice, because we logged in as Alice, or Bob, there's Bob Marley, or 345 Charlie Garcia. Make sense? All right. All right. We'll continue this in the next lesson. But from here, I think you have enough information that will allow you to complete the user service, login, registration, all those, and perhaps get you going with the website and pages. All right? All right. Let's see it here. Thank you.